Hey there, guys. We're picking up where we left off with the overview of Stats 1020, a good review for the final exam, and we're looking at all the different topics and concepts that we've reviewed over the course of the semester. So the first video dealt with chapters 1 through 5. We're going to pick up right here with chapter 6. And so chapter 6 introduced us to the normal distribution, or not really introduced us, but kind of brings it back a little bit and introduces it very formally. Now, chapter 6 was an important set of sections. We did 4 of them. And what it really does is sets the stage for a lot of our work in the inferential side of statistics. So we're still kind of in that transition. We dealt with descriptive statistics in chapters 1 through 3, the statistics that describe. Chapter 4 on probability was kind of a transitional time, and this one is kind of a transition as well to help us move into the inferential side of statistics. So the normal distribution is bell-shaped, it's symmetrical, and at the center are the mean, median, and mode. All of them are the same, they are equal. Okay, and we always describe normal distribution by its respective mean and standard deviation. We've got a notation that I introduced in the course because, of course, mathematicians, statisticians, we don't like to do all this writing. So it makes that a little bit easier for us. Now, what I introduced to you when I was providing this chapter in the class was that, the empirical rule has some limitations. And so, right, if we're not exactly 1, 2, or 3 standard deviations away on either side of the mean, then the empirical rule is useless to us. And so this chapter provides us with some alternatives. Remember that we looked at this in the context of 3 sort of different bins, if you will, of understanding the normal distribution. So one of those ideas was area under the curve. The second was finding probabilities of a single random variable. And the third context was a percentile. Okay, so those are the 3 things that we generally look at. So if the question asks you for any one of those 3, the procedure is exactly the same. So that's what's nice about this. All of the procedure is the same. Now, for those 3 questions, those contexts, we've got 4 cases. So you might remember area to the left, area to the right, area in between, and area in the tails. And that's what these pictures are showing you here. Remember that the chart on the formula sheet from our textbook always shows area to the left. Okay, and so we've got strategies that can help us to figure out then, well, how do we do the area to the right? How do we use the chart for the area between and area in the tail? So make sure you take a look at those if you're having some trouble. And what's nice is that this did come back in chapter 7. Okay, so that same idea did come back. And we did have to use it in sections 10.2 and 10.4 with hypothesis testing. So it was good that stuff did come back. So by now you guys should be experts in this, but just in case, go back and take a look if you're having some trouble. Now, chapter 7 said, okay, you know the stuff about the normal distribution, that's great, but now what we're going to do is instead of finding probabilities of individual random variables, what we're going to do now is find the probabilities of a sample, that we get a sample. And so that's what this section introduced us to. And in order to do that, we need to use something called the central limit theorem, or the CLT. Okay, and now as the 4th bullet point tells us, we still have our 4 cases that we had in chapter 6, area left, right, in between, and in the tails. And the key wording here was the probability that we get a sample, right, that does something, either sample proportion or sample mean. Those are the 2 contexts that we look at, and we've got some formulas that we have to use. If you guys remember, we did have a homework assignment in which I gave you some problems to tell the difference between chapter 6 and chapter 7 problems. So make sure you go back and take a look at that as well. And of course, we've got some formulas. So these are taken off the formula sheet, so I'm not going to rehash them here, but make sure you familiarize yourself with the vocabulary. Very important, okay? Especially as it pertains to this category here, which asks us the mean of the sampling distribution of sample proportions. Okay, so in other words, what's the mean here? Well, it's a little strange to talk about the mean when we're talking about proportions. And so what you do is you take it to be the population proportion. So that's what that is referring to. Okay, so make sure you're comfortable with that. And of course, this is the set of formulas for the mean. Okay, if you're dealing with the sample means, so make sure you have some familiarity with that as well. We did talk about it at length. It is on the formula sheet. Again, this is just meant to remind you that these formulas did exist. Now, moving into the next set of sections on chapter 8 and 9, this is where we start getting into some inferential statistics. So what these two chapters dealt with were confidence intervals. And so the basic idea here is what happens, or what do we do if we don't know the actual parameter, right? So the parameter, remember, describes the population. So what do you do if you don't know it? Well, the answer is you guess. Okay, so there's not a new idea. And it's not just a random guess, but it's a guess that's based on the sample, right? The data that we do collect. So we call that guess a point estimate. And so you see the vocabulary that's listed there. So make sure you come back to that vocabulary, very, very important. Now, when we talk about making a guess about the parameter, we do want to make sure that it is a reasonable guess. We don't want something that's just right way out there. And so what we do is we give this sort of confidence level to it, right? And what that confidence level is it's a probability. So as you increase the level of confidence, we increase the level of probability that that parameter is actually going to be in the interval, okay? And as a result, we do have more samples that we have to take. And there was a really cool picture that I showed you all what a 95% confidence interval actually looks like. So make sure you go back and you take a look at that, okay? Now, there's the last bullet point here. It says, in these cases, we don't know the parameter, and so that's why we're using the confidence interval. And so as a result of this, the formulas that we use then have to surround the statistics, right? Because that's what we're using then to make these assumptions on the parameter. And of course, we deal with the two categories, the mean or the proportion, so more formulas there. These are in the guided notes, so just a reminder of all the symbols. That stuff's going to come back to us. We've got a list of critical values. Okay, that's the z alpha over 2. So for example, if I was looking for the 95% confidence interval, I have to make sure to look at the value of 1.96 as the z alpha over 2 for 95%. Okay, so don't forget about that chart. That table is essential to use. And of course, these are the formal formulas, okay, to help us to obtain the margin of error. That's your quote-unquote wiggle room. Okay, so the formula there for means, the formula for proportions, and of course the formula for two means. So that's section 9.1, the two means. Okay, that's the chapter 9 piece to that. Now there's a question here. It says, notice that we use the sample proportion in the formula for proportions. The question is, why do you do that? Answer is very simple. We don't know what P is. That's why we're estimating it. So you have to use P hat in this case. And of course, there are the formal formulas themselves. The mean, you take the x bar, which is your point estimate, plus or minus that margin of error. That formula was on the previous slide. Same thing for the proportions, and then for the two means that are there. And I give you the language we use when we interpret the confidence intervals as well. And the last bullet point deals with section 9.1, where we've got two means, okay, and how to make that interpretation as well. So make sure you're comfortable writing a confidence statement. That's what that is. The other thing we looked at in these sections were minimum sample size. So we've got some formulas there, okay, for means and proportions. And then there were a couple of other notes about confidence intervals that we talked about. So the first bullet point here, what's the difference between a 95% and an 85% confidence interval? Well, the difference here, not just in the numbers themselves, but the 95% confidence interval contains more samples, okay, than the 85% confidence interval. And the reason that is because if you look at the percentage, what an 85% confidence interval says is if we take 100 samples, 85 will contain the true parameter. And in a 95% confidence interval, if we take 100 samples, 95 contain the parameter. So very obvious, 95% contains more samples. Increasing the sample size, what does that do to the confidence interval? That's very easy. It reduces the variation. And as a result, it narrows our confidence interval. So if somebody's worried that their 95% confidence interval is too large, it's too wide, then there is something that they can do, and that is to simply just increase the sample size, and that makes life a lot easier. And then this question here, what's meant by 80% confidence? I kind of answered that when we looked at the bullet point above that, which was if we take 100 samples, 80 of them are going to contain the true parameter. So this is some conceptual questions here and making sure that we really understand what these pieces to the confidence intervals actually mean. So I hope everybody was okay with that quick overview of chapters 6 through 9. What we're going to look at next are those that deal with the hypothesis tests.